So welcome everyone to our presentation today, and really nice that every one of you joined. We're really happy to tell you a little bit more about our Bundestag Chat, which is based on Rack systems. So we will dig deeper a little bit on how we built it, what it means to us, and what we learned along the way. And today, Piotr and me will be sharing these insights. We are both working for FieldM. So just really briefly, it's like a small analytics and data agency, which is probably one of the oldest ones in the German-speaking area, founded since 1999, and we are about 55 colleagues at the moment, located in 5 locations in Europe. And Piotr and me are part of the data product team where BI, data engineering, and data science come together. And our projects are done for several bigger and smaller customers throughout different industries. But I think that's already enough. So for our short background as an agenda for today, so what we brought, like a really short intro, since we're assuming that a lot of you already have potentially also heard in previous talks already what rack systems are, then describe a little bit of the components as we see it, then describe the challenges, because I perceive that as one still something which is not spoken about enough. And we introduce our open solution, share it also in a short demo, show it where you can also try it out. So everything is open source from what we are showing and can be directly used. Then some future directions, and ideally also have some discussion towards the end and want to hear from you what your thoughts are on this topic, maybe your experiences, but of course also any questions you might have. So what are actually rack systems? So generally, I think every one of us has been working with LLMs, so like your favorite chatbot. So you have some query which you address to it and you get some response. So that's rather simple at the moment. But the point is that this is also like your sole source of knowledge. And if you go once further, so you have potentially your opportunity, of course, give the LLM or like the chatbot some capabilities. So it can basically crawl some information from the internet and enrich the context. But it still remains that this is like the sole knowledge base. And the issue with that is potentially that you might have some internal knowledge or something which is proprietary to your specific organization. And this means that you might enrich your context or so basically your prompt with giving it specific documents. And this can be, of course, directly inserted, but there are also like better ways to better structure that, to also store that and make it available. And that's where rack systems come into play. So the idea is to have this as some additional private knowledge base, which helps the LLM to focus specifically on these documents which are relevant for your question at hand. You have access to your proprietary data. Of course, the question arises where you can send it to. So again, that's the question where the LLM is hosted, but maybe if you're locally hosted, that would not leave also your premises. And you can automatically update your data. So that also recently has maybe become less of an issue, since also LLMs or like the chatbots are constantly to one or the other extent updated. But still, if you have something which is really specific to your organization, this is how you could enrich it. And also due to the focus, due to this specific documents, you can also say, okay, please reference any suggestions or responses you might have and cite it and reduce to some extent the hallucinations. Where this actually comes into play, some real-life use cases could be, for example, Vimeo, which uses like the rack systems to ingest like summaries or like the transcribed audio from the videos. This can be then used by the users to search through the content. So that's one thing you could, for example, depending on what kind of data you have in-house or what your kind of main services focus around. This is something where RAG systems allow you to organize it, sort, and make it searchable. Another part is RAMP, industry classification. So it's like a financial operations platform. And they used it more or less towards the direction of applying their taxonomy to their customers. So it's more in the direction of like a classification system, basically. And they use the RAG systems to search through it. And one more artistic part, that's from the Warsaw Academy of Fine Arts. So they used like also a chatbot, which was relying of a RAG system in the background, with which you could then have an exchange, so like speech-to-speech chatbot, and in the background would allow you to search specific information about the arts which they are currently having in the exhibition, and to find like new ways of interacting with the visitors of these exhibitions. So like just like give you an idea of like the 3 potential application areas, but also how very differently they can be. And that might be also like a little bit of an outlook what the difficulties with building these specific systems are. Of course, there are different alternatives. So the RAG system itself in the middle, to which we will come also on the couple of next slides. You could theoretically, by growing capabilities, context length of the offerings from the chatbots, just put these documents in like a long context injection. But this comes with some disadvantages, or like every solution, I think, particularly in 2025, needs an agentic version. So that's also towards the RAG systems, that you have like agents which help you to organize your inputs, also search for you, and have to be coordinated. The advantages and disadvantages of this long context injection, for example, is so like it's rather simple design, low latency, so you don't have to build anything specific. Systems can handle that out of the box already, but the problem is, of course, it has to scale with the data volume which you have, and the more context or the more of these documents you put, the less focused the model might be in the end in the responses, because it has to, of course, go through a lot of more kind of tokens for the input. So the scalability ends at some point, and it's also difficult to orchestrate because you then have to go into the context engineering part to be more specific, addressing it to one specific aspect of the provided documents. The RAG systems have some lower hallucination risks. They are potentially good in their scalability, depending, of course, always on the strategy which you decide on for building your RAG systems. So there are also nowadays plenty of them, but Piotr will go a little bit more into the details. You have moderate costs. There are already quite some libraries which have been evolved, also open source tools, but of course, you can also buy them from the bigger vendors. You have some moderate design complexity. And the agentic RAG system, that would be more at the upper end. So very low hallucination risk by assuming that your agents do what they are supposed to do when you let them loose. You have some good observability when you kind of follow up how they align and exchange on each other. And you can quite well scale and let them search through a vast amount of documents or vector stores in the end. But the design is, of course, complex, because potentially you don't have to control one agent, but like a system of agents. You have a higher latency because the communication, the back and forth, will cost some time. And also potentially the costs are much higher. So building such a system or maintaining it, or what you have to pay in token-wise. So one thing which we want to already share as some take-home or take-away part is that this oversimplified representation on the left, how RAG system could work, is of course something which you have maybe in a notebook, something which you can build within a couple of hours and get it running. But what Piotr will go into more detail is that it needs like several components which need to interact and be linked and optimized to get it really into a productive setup. And this is like a major setup which we observe also, that it's at a first glance rather easy. At a second glance, you will spend some significant amount of time of designing and optimizing the systems.
Yes, and now we'll speak a little about the anatomy of rack systems. This is a schema we've seen from the previous slides, where we can distinguish 4 main components, like extraction part, where we take care of our data sources, parse them, clean them, etc. Later on, they are passed to embedding part, where we again might need to process it in order to feed it to an embedding model that we have to choose according to the use case we are handling. And later on, we have retrieval augmentation, where there are plenty of retrieval methods, which we'll talk a little later on. And based on that, it retrieves the relevant nodes that later we augment into our context. And based on that, we generate our response to the user. And at the end, we have the evaluation scope, where we basically try to estimate the performance of our system overall. And seeing like overall components, we can see some of the challenges, where the first one is like the number of these components that have to be integrated together. And also the issue of configurability, because by implementing something, we want to also be able to prototype fast and test different things in a rapid way. So this also matters. And in case we want to go outside of the POC level, we also need to prepare the code base to scale it up for production cases. Nevertheless, we cannot forget about monitoring, because on the bigger setups, it is necessary to be able to recognize bottlenecks and then apply potential solutions. And at the same time, we have to have a way to evaluate our changes in order to see if it's progressing or regressing. And as always in the data world, we have to take care of the privacy. So whatever we are consuming from the extraction part, we have to take care that it complies with all the legal basis. And as well, we need to be aware that either users or answers from the LLMs can have a harmful impact on the users itself. So we have to take care of it as well. And the whole problem that we encounter is that these single components are solved by many solutions, even open source ones, but rather one by one. There's no like all-in-one solution that covers all of it together. And this is the place where we wanted to introduce our solution. Here you can see just an instance of the template that I showed you before, as well 4 services that take care of these different things connected with Vector Store. And how we build it, we built a code base which we wanted to make suitable for many use cases. So we don't have to take care of the cumbersome code and implementing it over and over whenever the use case comes in, but rather we try to make it so we can easily tweak the configuration, like data sources, used LLMs, embedding models, vector source, or retrieval methods through the config file, which is in our case a JSON. And based on we are using the same code base, different configs, and in this way we are able to create different use cases. We also took care of some integrations with UI. In this case, we are using Chainlit for monitoring. We are using Langfuse, and we also provide integrations to vector stores like Qdron, ChromaDB, or Postgre. Which one you choose depends on your needs. Some of them are faster, some of them are more powerful, more convenient. This is also one of the components you have to take care when you identify your use case. And of course, evaluation. So the first step is to basically build a data set. If you're lucky, you can have some data set that you can use within your organization, the manual one. Other way is to create some synthetical data, can be with the usage of LLMs to create such data sets. The third option we offer is human feedback. We'll see later that in the chat interface, we provide thumb up, thumb down functionality of the response, and ones that are thumbed up, we save in the dataset, evaluation dataset, later for checking performance of our system. And we do it by using the metrics from a Ragas framework, where we use LLMs as a judge as well in order to check if the responses are getting better or worse. We took care also of the deployment process, so to make it smooth and easy for anyone who wants to start working with it, we containerized everything, and in this way it's easily deployed on any other machine. And here I wanted to show you a short demo how it works. And as you can see, this is our demo where we can see how the chat works itself. We get the answer. We can see that we will use. We can see the references used for the answer, the feedback functionality that I talk about, and at the end we can see that the feedback has been updated. In the next view, we can see the Langfuse platform, which we use for monitoring. You can see a lot of metrics regarding our system over here, which helps us to take care of it and find potential problems. We can see also details about each trace, which is basically a question from the user, and see how the whole pipeline worked for that. And the next thing is the scores. So basically the feedback from our users and the data sets where we store the results and the data sets, evaluation data sets itself. And what are our learnings? So from building the use cases, what we've learned is we have to define it at the very beginning. We have to define if the users will speak English only to the chat, or we need to take care of the multilingual problem. If users would rather ask only for the most recent documents, or we have to take care of some summarization tasks as well. And the next thing is, of course, data quality, where we need to also make sure that the data sources it's based on are sufficient in order to prevent hallucinations. And as already we stressed before, we need to take care of evaluation. So we need to provide this automatic evaluation that we talked about. We also need to include some humans into the loop to make sure that everything is running properly. And we need to be ready for extending the current setup, but scale it up as well. So whenever we develop something, we have to keep it in mind as well. And now I'll give boost back to Matthias about future directions.
Yeah, so we are still learning on this project, and it helped us to see several disadvantages and advantages of RAG systems. We currently optimize it for hosting it locally, because also not sharing or placing in the documents somewhere else, but like a cloud setup will be important. Further optimization, so on the retrieval process, but also purely on the data ingestion and embedding part, are ongoing, and learn from the feedback we gather from our user. And finally, also to think about further integrations. And that's where we are heading, but what we see also, like from industry-wise, and that's the difficulty sometimes, because our solution evolves, but in parallel also you have to keep an eye on the different other aspects around it. Meaning that for the industry part, so if you switch on the next slide. Yeah, so like you have these agentic RAG systems, which are briefly touched already, but where you have like someone who's capable of picking the right retriever, for the right task. Also that you have potentially also the idea of more federated rack systems so that you don't have to bring everything in one place, but you have different vector stores potentially throughout different organizations or within your departments, which would then be retrieved and or used for the retrieval process and shared with your LLM in the end. And you have, of course, the maybe not so trending or buzzing topic of context engineer in 2025 anymore, but still a huge topic where you move from the pure like setting up how something should be done, but more see how can I best provide my LLM with the right context and point it to, okay, this is where the focus needs to be done, and how can make best use of the context or the window which is available to me. And if you want to try it out, our solution can be found on GitHub. So as I said in the beginning, so this one is definitely open source. We are happy for any feedback or idea or also like contributions to it. And yeah, as I said, it's the idea is to have it freely available. And that would be it for now for our presentation. You can also try out the chat interface for the Bundestag Chat with the documents. Also, their feedback is highly appreciated. And I thank everyone for your time and attention, and would be also happy for any further questions.
Okay, so I can see one question. What strategies do you use to improve RAG system based on user feedback? So first of all, we look at the scoring of our evaluations, and if we see that it regresses, we can also see one by one on which questions it does, and then we try to look for some pattern within the questions that it's failing. Let's say if the questions are about what was the information X and Y a week ago, what was the information over the last 3 months, we can see that, for instance, this is obviously a problem with a temporal reasoning of our system. So then we say, okay, that's the point, and we have to find a solution how to make our RAG system understand the time and understand when the documents are relevant. So that's the one example how we deal with such things.
And yeah, so, and of course we can share the slides. So can ping us either on LinkedIn, or I'm not sure if we can also distribute it here somewhere directly. But yeah, the idea is again to share as much as we have about it. And maybe one last thing to the learning for the users. So I think it's always like twofold from learning from the metrics which we see, and the other one is for the qualitative user feedback. So having specific people who are either also working for Parliament or like having a mandate in that direction. So looking at a little bit different in it, but also like asking like specific colleagues or power users for that matter, and constantly see where you have to improve, where like the responses are not expected, or you're lacking details. So I think this is like coming from both ends, and that's maybe also the tricky part. And that's where you can spend some significant amount of time actually. All right. Then I would say thanks everybody again. It's great of being part of the conference, and I wish you all a great rest of the conference with some other amazing talks. It was nice to see you virtually.
Yeah, also thank you a lot.